So here's the final question on the Edexcel C34 International paper. It's an integration question starting off with the trapezium rule. Trapezium rule is normally a very, very easy source of marks, but also strangely easy to lose marks as well if you just rush it and don't take care. This one in particular doesn't have kind of conventional intervals between them. We often see things with, intervals of 1 between them or 2 or whatever. But here we've got a bit of a strange one. H is equal to that, basically doing that, take away that, b minus a over the number of strips, which is 2 in this case. Or alternatively, we'll find the difference between these two. Anyway, first things first, all we have to do for the question A is complete the table, so we're just putting that number in there, which is and it wants it to 4 decimal places, so that's 0.999, there we go. Right, okay, so that's the first question. The second question is to use the trapezium rule. Okay, let's change the colour to blue. Okay, so trapezium rule, h over 2, so the area is approximately equal to h over 2, and h is e squared minus e over 2, so it's over 4. The first ordinate, which is 1. The second ordinate, which is 0, plus that, plus 2 times, there's only one middle one here, that. And they want it to 3 decimal places, but I'm still putting the exact answer in that I have stored on my calculator for that just in case. And I'm getting the answer 2.055. And that's part B. Okay, that's pretty simple for our last question, but we're then going to go on to some integration. Let's make a bit more room here. And it's telling us to use integration by parts, but really we should know that this is integration by parts for integrating a ln or a ln squared. I suppose there's a few different approaches. Some people, in fact the majority of students I've seen done this, do it by ln x times ln x. Some do by doing the 1 times ln x squared. And I've even seen a substitution employed of u equals ln x, and it works out by parts. Now, really these two are the most common. And probably more students have gone for the first one, and there's no reason why we shouldn't really, so that's what I'm going to do. If you do this, you need to be careful that you use the chain rule correctly when you differentiate this. I'm going to stick with, let's say, what majority of students have done here, which is to call it ln x times ln x. But in order to do that, I might put this back into a different colour here, into red. We need to be able to integrate ln x. And if we integrate that by parts, we can say that u equals to dv by dx, should I say, equals to 1. And u equals to ln x. And then if we do it like that, we can see that it's going to be uv, which is x ln x, minus v, which is x, times by the integral of 1 over x, dx, which is the integral of 1. So ln x integrated is ln x minus x. I haven't really gone all the way to answering this yet, but I'm surely going to need to know how to do that before I do anything, so that's why I've done that separately. So now when I've looking at integrating ln x, I can call one bit equal to u equals ln x, and I can call my dv by dx also equal to ln x, and so that means du by dx is 1 over x, and v is equal to, and now we know that now, x ln x minus x, and I can put that into my integrating by parts formula. So we've got that is equal to uv, so that's ln x times by x ln x minus x, minus the integral of v du by dx, which is those two multiplied by each other, 1 over x bracket x ln x minus x dx. That equals to, there's obviously a common factor of minus, this is a common factor of x there, so that's integrating ln x minus 1 dx. So I also know what that equals to, because I've got all of this above, x ln x minus x, minus the integral of ln x, which is x ln x, plus x, because of two minuses. I've also got a double minus here as well, so that's plus another x. So if I multiply that out, that tells us that the integral of ln x squared, which is what I've started with at the top here, is equal to x ln x squared from that multiplied out together, so that's x ln x squared, minus 2, now I've got two of these, minus 2x, I've got two of these because I've got one there and one when I multiply those two out, so that's 2x ln x, and I've also got 2x here. I better put my plus c in at this stage, it does have it written in the question. Didn't really need to write, I perhaps should write it there as well, but we don't need to write it in the intermediate stages in between. Okay, so that is that as required. We've done it, we've done that more repetitive than anything else. Right, now it's talked about this thing being integrated around, and we have a formula for we have a formula for integrating and finding a volume. So the volume is equal to pi, the integral between the limits of e squared to e of ln, it's of the actual function squared, which is 2 minus ln x squared dx. Okay, now that equals, I'm going to have to multiply this out, let's say more fiddly than anything else this question, pi, we haven't integrated yet, let's not jump the gun, e squared e, 4 minus 2 ln x, no, minus 4 ln x, plus ln x squared dx. Now we can integrate each of these individual parts, so that's, again we've got pi there outside, 4x minus 4 times this one, so that's minus 4 ln x plus 4x, because it's 4 times this and we need to be careful with our double minuses, so that's that part. Is that the plus x, if you see the double minus, be careful with that, plus the integral of ln x squared, which is the whole lot of this. So that's plus x ln x squared minus 2x ln x plus 2x, and we don't need the c here because we've got limits. Right, now let's bring this together. We've got a 4x plus a 4x plus a 2x there. So that equals square brackets 10x pi in front minus I think there was a there should be an x there, so it's minus 6x ln x, okay, plus x ln x squared so now that's tidied up, we're just in a position to be able to put the limits in. Okay, now notice it here that e squared, ln of e squared is 2 and ln of e is 1. So I'm using those two facts in working this out now. I'll write that down. Ln e squared equals 2 and ln e equals 1. So that should help us to put our limits in. So let's just put the first bracket in. Pi times 10 e squared minus 6 e squared times by 2 because of ln e squared plus e squared times by 2 squared minus, still got a pi there because pi is on a multiple of everything, that's 10 e minus 6e times 1 because of ln e plus e times 1 squared, and that equals to, working all this out, there's 10e squared here, there's 12e squared here, and there's 4e squared there, so that's 10 minus 12, which is minus 2, plus 4, so that's 2 pi e squared, and this bit here 10e minus 6e, which is 4e, plus e, which is 5e, so that's minus 5 pi e. Let's factorise that nicely because it wants it in that form. So the final answer is 2 pi e bracket 2 minus 5, 2e minus 5, and that's our area, and that's that question done. Reasonably, it's quite long, more than it was difficult, but also lots of potential for accuracy errors as well. Okay, that's it. Last question of the paper done. Didn't think it was too bad overall.